There are places in our universe that call to us, frontiers of knowledge, silent and dark at the edge of our solar system. We are explorers by nature, always wondering what lies beyond the familiar. Our journey takes us to Sedna, a world so distant it challenges everything we know. Imagine yourself aboard a ship built to cross the void, venturing into the unknown. Sedna calls to us from the edge and we answer. This is the story of our voyage to the solar frontier. After a journey spanning decades, the Odyssey's sensors detect a faint object ahead. It's not a star, but a ghost, Sedna, reflecting the last faint rays of a distant sun. At first, it's a single pixel on a screen, but as we draw closer, a world emerges from the darkness. Sedna's surface is not grey, but a distinct reddish hue, one of the reddest objects in the solar system. Scientists believe this color comes from tholins, complex organic compounds created by cosmic rays over billions of years. Sedna is a cosmic fossil, its surface preserving the chemical history of the outer solar system. As we approach, the landscape reveals profound age and stillness, craters, but fewer than expected. Is there cryovolcanism, or has time simply erased the scars of ancient impacts? There are no clouds, no oceans, just silent, frozen terrain under faint starlight. Seeing Sedna for the first time is humbling. It has existed in isolation for eons, following its lonely path. Now, for the first time, it is being watched. Our ship's light, the first new illumination in billions of years. We are intruders in its silent kingdom, here to listen to its story written in ice and rock. Sedna's tale is one of survival at the edge of everything. It is a world painted by time and radiation, beautiful in its desolation. Every new image poses more questions than answers. We are here to witness, to learn, and to bring Sedna's story home. What is Sedna made of? It's a dwarf planet, about 1,000 kilometers across, locked in a deep freeze. Surface temperatures hover around minus 240 degrees Celsius, so cold that nitrogen freezes solid. Beneath its reddish, tholin-covered surface, Sedna is likely a mix of rock, water ice, methane and nitrogen. It has no atmosphere. Any gases have long since frozen onto the ground. There is no wind, no weather. Only the slow crawl of shadows as Sedna rotates every 10 hours. Could there be a subsurface ocean? Unlikely. Sedna is too small and too cold to retain internal heat. It is likely frozen solid, a monument to the power of cold, preserved for billions of years. Yet, even in this stillness, Sedna's composition tells us about the ingredients present when planets formed. Water ice and organic molecules connect it to the building blocks of life, the same materials found in comets. Sedna is a time capsule, a sample of the primordial solar nebula, perfectly preserved in the deep freeze. How do you find something so small, so dark, and so far away? In 2003, astronomers Mike Brown, Chad Trujillo, and David Rabinowitz scanned the sky for faint, slow-moving objects. Using a robotic telescope and powerful computers, they compared thousands of images, searching for a moving dot of light. On November 14th, their software flagged an object, faint, slow, and incredibly distant. It was more than 3 times farther from the Sun than Pluto, the most distant object ever seen at the time. They named it Sedna, after the Inuit goddess of the sea, a fitting name for a world in the cold, dark depths of space. The discovery was a landmark, proving our solar system was bigger and stranger than we imagined. Sedna opened up a new region for exploration, the inner Oort cloud. It was the first resident we'd met from this mysterious realm, a ghost from the fringes. Its existence challenged our models of solar system formation. Sedna was a puzzle, hinting that a crucial piece of our solar system's history was still missing. Its discovery changed our understanding of the solar system's boundaries. Sedna became a messenger from the edge, inviting us to look further. Sedna's orbit is unlike any other. It's wildly elongated, a stretched-out ellipse through the outer solar system. A single year on Sedna takes over 11,000 Earth years. The last time it was here, humans were just learning to farm. Even at its closest, Sedna is 76 times farther from the Sun than Earth, At its farthest, nearly 1,000 times. The Sun is just a bright star, providing little light or heat. How did Sedna get here? It's too far from Neptune to have been pushed out, but too close to have formed in the distant Oort cloud. Sedna lives in a no-man's land, detached from the rest of the solar system. Its lonely path is a clue, evidence of a violent, chaotic past. Something powerful must have disturbed its original orbit, flinging it onto this strange trajectory. The answer isn't Neptune. It must lie elsewhere. Sedna's orbit is a breadcrumb trail, leading us back to a dramatic event in our solar system's history. It's a mystery that challenges everything we thought we knew. Sedna's path is a window into the solar system's ancient past. What could have thrown Sedna onto its lonely path? Scientists have several theories. Perhaps our Sun was born in a crowded star cluster, and a passing star's gravity kicked Sedna into its current orbit. Or maybe Sedna was captured from another star system, a cosmic immigrant. But the most compelling idea is Planet 9, a hidden giant, 5 to 10 times Earth's mass, lurking far beyond Neptune. This planet's gravity could explain Sedna's orbit and those of other distant objects, all clustered as if shepherded by an unseen force. The hunt for Planet 9 is on, inspired by Sedna's discovery. If found, it would revolutionize our understanding of the solar system. Sedna is not just a destination, it's a signpost pointing to even greater mysteries. Every new world we discover forces us to ask, who are we? Where did we come from? Sedna in its cold solitude is more than a ball of ice and rock. It's a piece of the cosmic puzzle. Its surface and orbit tell stories of chemistry, time, and a violent past. Sedna reminds us our solar system is dynamic, with secrets still hidden in its darkest corners. The quest to understand Sedna reflects our curiosity. We look to the horizon and wonder what lies beyond. Objects like Sedna are the new frontiers, challenging our technology and inspiring us to dream bigger. Each discovery adds to the puzzle of Planet 9 and the story of our solar system's formation. These distant worlds are fossils of planet formation, preserved where time moves slowly. By studying them, we do cosmic archaeology, digging into the past to understand our present. The journey to Sedna is a journey back to ourselves, to the chain of events that led to Earth and life. The story of Sedna is part of our story, a reminder of the grand cosmic dance we all share. As we look into the void, we search not just for new worlds, but for our own place among the stars.